what we were doing.
So we are discussing problems.
Problems on which chapter?
Simple harmonic motion, time period finding time
Oh,
period.
okay. Okay. So we will do simple harmonic motion. So let's start with some J questions. I'm sharing 1 minute. So I have shared the screen. Check it. Screen is visible to you. Screen is visible. Screen is visible or not?
The screen is visible, sir.
Okay. So you can start with this question. But 1 minute, not this one, not this one. Uh, uh-huh. Okay, you can start with this one. This ITJ 2010 question. Start with this. Question is visible to you?
Yes, sir. Question is visible, sir.
Okay, start with this question. You can just tell me the equations. No need to find the final answer. You can just tell me the equations and we can go to the next. You can ask your doubt or you can tell me the equations. Here you will have to apply some of the concepts of elasticity also. You know, stress, strain, these relationship.
I don't,
You know or you don't know?
I don't know, sir.
Okay, so if you don't know, then leave it. After that, stress, strain, and studying all this, you can answer this question. So leave it, then we'll go to some other. Now you can try this question. You can try this question. Question is visible to you?
Yes, sir. Definitely, sir.
Okay, try this. Are you getting?
So getting 7.
Okay. So what you did?
So directly, I think we can apply the formula.
Which formula?
Time, time of head of projectile we can apply. So 2u sin theta by g.
Yes, yes. So this question, no need to apply any concept of SHM. Directly you can do.
Yes.
Directly you can apply the for the vertical motion of the stone. That's it. Okay. That's it. That is, you will get the correct answer. This is a lengthy one. Okay. We will do some questions, then we'll come to. You can try this one, or you can just explain the process and then we can go to the next. So IIT JEE 2011 paper 2. So here you have to see that when you add, when the same mass is subjected to two or more simultaneous sinusoidal displacement, you have to understand that each equation of displacement is an equation of SHM. This is also equation of SHM. Both the SHM is done by the same mass. So the overall motion will be a combination of this and this. Now the thing is that
How
after
to,
adding a third sinusoidal displacement brings the mass to a complete rest. So due to superposition of these two SHM, resulting motion will have some amplitude and then when the third displacement is subjected, then it comes to complete rest. Here you can treat and this displacements are actually vector quantity. Here you can simply do the vector addition of the displacements, assuming the difference between them is that there is a difference of phase, here omega t plus 2 pi by 3. Amplitude is same, so if the first one is represented by a vector of amplitude a, second one is also a vector of amplitude a, but the difference is between them is the angle between them, and you will take the angle between them as their phase difference. Phase difference is 2 pi by 3, means 120 degree, like this. This is also represents a amplitude a, and this represents amplitude a. Now the resulting motion will also be a SHM of amplitude, whose amplitude is given by vector addition of these two. Angle between them you will take as the phase difference. You will take phase difference as the angle between them. What is phase difference? 2 pi by 3. 2 pi by 3 means 120 degree. So 120 degree. Now when third displacement is added, it brings the mass to rest. So what you think, what you will do?
So how can a particle undergo two thrusters at a time, sir?
Yes, so why not? Like it is not going to displacement at a time. It is doing superposition of these two.
Superposition means what, sir? So sinusoidal means what, sir? I'm not
Sinusoidal simply means a function of sine. Superposition means that suppose on a particle a single restoring force is acting, so it will do a SHM. But if two restoring forces are acting, then the resulting motion will be actually a superposition of these two.
means we can say that this is the
Resultant of these two, you can say. You can say that if this is the only equation, suppose, then it is SHM. If this is the only equation, then this is also SHM. But now both are there. Both combined will be a SHM of a different amplitude. And different phase. So it is actually that the same point mass is subjected to two simultaneous, means at the same time, two displacements. So two displacement does not mean that particle will have two displacement. Particle will have only one displacement, but that displacement will be, you can say, addition of this and this. So vector addition of this and this. For example, so x overall xt will be actually x1t plus x2t. This is the equation. Are you getting? It is not that it has two displacement. Displacement is not two. Displacement is the addition of these two. This one.
So we can say vector addition. So we can say that this is the simple harmonic motion of the. We can say the restoring force is the net resultant force of the two forces. We can say.
Hmm. Yes. So the resulting motion will be a SHM whose amplitude you can find by vector addition. But while doing vector addition, what angle you will take? Angle will be equal to phase difference. So here this angle will be equal to the phase difference, which is here 2 pi by 3. Yeah, you can ask your doubts. Keep asking.
Yeah, understood. Right.
Okay. You can ask your doubt.
resultant amplitude will be A no, sir.
Resultant of these two.
Yes, sir.
Yes.
These two will
Yes.
be A no, sir.
Yes. So what is the answer to this question?
Yes, sir. CBT. Sir, B, sir. A bomb material.
Yes, that is the correct answer. So the third vector should be such that it would cancel out, right? You
Yes, sir.
already know that three vectors of equal magnitude
Yes, sir.
arranged in such a way that if angle between any two adjacent is 120 degree, then the resultant will be 0.
Yes, sir.
So simply you can apply that concept and you will get the answer. Okay, so you can try this question. So this is IIT JEE 2011 paper 2. Right.
No, electricity. I think.
Sorry,
Sir, I don't know electricity, sir.
you don't know really?
Yes, that much deeply though.
That much deeply not required. Only very, very basic required. Deeply not required. Very, very basic required. I hope you got the answer.
It will be same frequency. I think main position just will be shifted now, sir, with the same frequency.
You are saying option A, right?
Uh, it's option is main position.
What
In
about
this
option B? What about option B? That should be the correct. First should be the correct. Is the correct. Understood. You can ask your doubt. You can ask your doubt. I think you don't have any doubt.
Sir, in my, sir, I assume that hello.
Yes.
Generally, we know that sir, we can say frequency or time period. We can say depends on it. It does not depend on any external force. So we can say frequency or time period. So
So if there
sometimes we
is
can say
a, you cannot say it does not depend on any external force. You can say that if a constant external force is acting, then it does not depend on that constant external force. Constant external force. That constant external force is not the restoring force. QE.
so if the
Which is
force is
what is the restoring force here?
that means if the force is variable, then it will affect the frequency. So the time period of frequency.
So when you are saying force is variable, then the motion may not be SHM itself. It should be variable, but then variable in such a way that it should satisfy that proportion directly
Yes,
proportional to x. Are you getting?
yes, sir.
Yeah. So, but then it will become restoring force. So time period does not depend on an external constant forces there, because that is not the restoring force.
Yes, sir.
So it depends on restoring
Spring
force.
force. Yes, sir.
Okay. Now you can try this one. Understood the question. This is the remaining part of it.